get back to it. Let's get back to work. So, second part of this presentation. So, we talk about how to connect with Bitcoin. Now, let's talk about how to connect with the Web2 world. So, essentially, we're trying to answer the problem that has been also a huge problem for all blockchains. Essentially, how to get information outside of the blockchain. So, you have a contract, smart contract, let's say on Ethereum, and you want to access information that is not on Ethereum. For example, the weather of today is not going to be on the blockchain. And maybe you need that information to settle a smart contract. So in our example, it would be like a farmer. Maybe we have an insurance protocol that is built on Ethereum, and it needs to know if there was like a thunderstorm or some kind of problem with the weather. So what we do at the moment is using an oracle, for example, Chainlink. Chainlink is going to be the intermediary between the smart contract and the Web2 world. So Chainlink will query the weather API and will write in the smart contract on Ethereum, which is going to be a new smart contract, oracle contract. And essentially the smart contract or original smart contract on the left is going to query this oracle contract and receive the information. So that has been an issue since the beginning of all blockchains. And as we've done with Bitcoin, on ICP, we are using a different approach, which is native approach. Essentially, canisters can directly make HTTP outcalls to external entities. So they are able to directly call the API in a similar fashion as the Bitcoin integration, await management canister.http request, call the weather API, receive the response directly on chain to the canister. How does it work? Well, let's do it step by step. So there are 3 important steps. And yeah, okay. So the first step is going to be all nodes querying the API. So all nodes are able to perform HTTP requests on their own because they are servers. So they're just doing their HTTP request. Then they are settling that on chain. So they need to come on a consensus. They need to reach an agreement on what is the result of the HTTP request. And actually, this part is not easy because what happens if you do a multiple request? You are going to have different results because if you query, for example, the price of ICP on the API of an exchange like Coinbase or Binance, even a slight delay between the nodes of like a milliseconds can change the result of the HTTP request. And the same with the weather, you can have a slight delay between the nodes and they won't receive exactly the same answer, but we need them to reach an agreement. So we will see how we can solve this problem. And then once this is, once there is a consensus and it's part of the block, we can add that and return the answer to the management canister and then to the canister that made the call. So how to reach consensus? There is a concept of a transform method, which you can see on the right. So essentially, we are in a situation where we have 3 nodes, and those 3 nodes, they are sending a request for the weather of today, and they are receiving the temperature, and they receive a slightly different result. The first one would be 27.25, second one 27.26, and then 27.24. You can all agree that they are basically telling the same, like they have the same weather, but not exactly the same. So how do we fix that? We provide a transform method, which is going to transform the result that we receive and accept, I would say, a range of values that is okay or not. And in our example, let's say we have a function that only keeps the first 2 decimals, or just the whole part of the number, not the decimals. Then yes, we actually have exactly the same value because all of them are telling us that the weather right now is 27 degrees. So this transform method is super important. And also, of course, we need to make sure that if there is a malicious node, so for example, on the left, we need to make sure that this malicious node won't be able to influence the final result. So essentially, you have the majority of the nodes, two-thirds of the node that take a decision on the result. So if you have more than two-thirds of them, then you can reach an agreement. It's just the same as normal ICP consensus. Okay, so the use cases, there are quite a few use cases. For example, the first one would be this exchange rate canister. Exchange rate canister, I can show you. Let me remove that and that. The exchange rate canister is here. The exchange rate canister provides an Oracle service for cryptocurrency and fiat currency exchange rates. It interacts with all data sources using the HTTP Outcalls feature. So this is able to give you the exchange rate for any currency that is listed here. Let me show you where is the canister IDs. So yeah, it's here. So if we go to the dashboard and we check this canister, get exchange rates, we are able to let's say ICP, maybe we can try ICP to USD. Let's see. It rejected the message for some reason. I'm not sure exactly why. Maybe it's like ICP like this and USD like this. Okay, so we cannot call it for some reason. But yeah, essentially it's giving exchange rate for assets. So for example, ICP to USD or Bitcoin to USD and so on. Another one would be social media. So essentially able to make integration like from a canister to the Twitter API or the Instagram API. So bridging the gap between Web3 application and Web2 application, this is a major issue and major use case because the transition from Web2 to Web3 needs to be smooth to the majority of users. So the users that, like 99% of users that don't really care if it's on Web2 or Web3, they need smooth integration. They need to feel familiar. And I think in the end, of course, Web3 will be a replacement for all the Web2 platforms, but in a transitory phase, it's important to have integration with existing platforms. Payment gateways, so of course we have crypto to pay, but we could also use traditional methods like Stripe, and we could integrate through HTTP outcalls. IoT devices, it's a big one. A few projects on ICP are building gateways for IoT devices on ICP. Ethereum, so again, we need this HTTP outcalls to be able to call Ethereum and Ethereum nodes and interact with them. And artificial intelligence, of course, a final one for HTTP outcalls. How expensive is an HTTP outcall and how can the cycle consume be calculated? So it's a pretty expensive operation, but because it needs to be settled on chain and there are quite a few computation going on for that. So it's not as cheap as like a normal intercanister call. Let me check actually, but it has been improving a lot recently. I do not know the exact cost by heart, exactly how much it is, but So it's here for sending an HTTP out call to a server outside ICP. This is the number of cycles. So this doesn't give us like a price in dollar, but I think it's a few cents per HTTP out calls. If you compute how much dollar or like how much ICP you need to get those cycles, it would be around a few cents, like 0.1 probably. Okay, so that's it for the theory. And if you want to read more about it, it's here in the advanced features, HTTP out calls. You can read about that here. I send the link in the chat. Now, let's go back to our example and try to query the price of ICP from the Coinbase API. So examples, Motoko and HTTP get this one. So actually, let me move inside. So Motoko HTTP. All right. So this looks fairly simple compared to the Bitcoin example. We have only 2 files. The purpose of this application is to give developers a minimal application that use the IC HTTP outcalls feature to make a GET request. If you want to start working, no, we don't need that. So, oops. Yeah. So I can start my local replica. And let me show you how it's done. So as you can see, we again have this idea of a management canister. The management canister, you remember the actor is specified as an empty blob. So this is the canister ID, I would say. And we instantiate the type from types.ic. And this is here. We have an actor where we can do an HTTP request. So here we are declaring the interface of the management canister, but only the method that we need. So of course there would be more methods, but we only have this HTTP request. So we declare it, and then basically we specify the API. So this is the API of Coinbase that we want to query. Then we need to, of course, make the headers for the request. And finally made the HTTP request. So here we are making it. Something important is that we need to add some cycles to pay for HTTP requests. If we don't transfer them explicitly, the code might fail, unfortunately. So you have to know how much in advance it will cost, and you need to add those cycles. So it's going to take from your canister those cycles, add them to the call, and return the remaining cycles to your canister. So then we are making the requests through the HTTP, through the management canister. And then we are just returning the request. And I think we are just decoding it. So and this is the transform method that I've talked about. It's here, it's specified here. So this is a transform context. We are specifying a function and a context. So you can take a look at the function, at the type transform context. Where is this? So those are the types for making HTTP request in Motoko, HTTP header, HTTP method. And actually, this afternoon we will build a canister that can answer HTTP requests. So it's going to be different. It's going to be the opposite. What we are doing right now, it's making a HTTP call. And what we will do this afternoon is receiving an HTTP call to our canister. So this is here, transform arguments. Okay, so let's try it out. I think it's possible that we run into some issues, but we should be able to fix it in case we have them. So I'll only deploy locally, and I'm hoping that locally we can make the calls. All right, so our canister is deployed. Let's try to get the ICP-USD exchange. So this should return. Okay, so it returned the price, but I don't think it's the current price because it's from an earlier date. So I think a fun challenge. So yeah, those are the timestamps from May 1, 2023. So let's actually do something fun and try to update that to the current prices, and we should look at the Unix timestamp right now. So this is the current time, and well, let's maybe do it to make sure, because I don't know if the API is accessible, if there is maybe a delay, like we cannot access the last minute maybe. So let's make something safe and do something from yesterday. So yesterday at 11 in the morning. So this was the current timestamp. So this is start timestamp. And oops. And maybe until 11:01. So yeah, of course, it's just going to be plus 60. Okay. And try to deploy that. So we should see a different result. Right now, the price was around $5, $5, $7. Right now, it should be at around 12, 13, something like this. So let's see if this still works. Okay, great. So yeah, it seems to have worked. So we have the current, well, the price from yesterday, so 13.36. That was the minimum price, and the average price, I guess. Yes, start timestamp, lowest price, highest price, price open, price at close. And the volume of ICP traded. Okay, great. So this is how you can make HTTP requests. If you have more question, I'll send this link also in the chat. Okay, it's sent in the chat. How do you convert the timestamp to a date and time in Motoko? How do you convert this to a day, to a date and time? So I'm not sure I understand exactly what you want to do or what is the question about, but in Motoko, you can get the time from the time library. So you can get the current time from the time library, and you can do is equal time.now. It's going to give you the current time And unfortunately, so yeah, let me show you. This is the time library. So it's a very simple library. Time is represented by a int, and it's the nanoseconds since 1970. So it's the Unix time. And you can only have, well, you only have one function, which is time.now. So you're not going to have it in, this one I think is in seconds. And what you're going to have in Motoko is going to be nanoseconds. So you need to convert that back depending on, well, depending on the API you're using or what is the format that you should be respecting. I can show you like, let's do it through the Candid interface, get time. And so this is how you have the time in Motoko. As you can see, it's very long because it's nanoseconds. So you would need to convert that to maybe to seconds or even to days. Then it's going to be a computation and conversion. I think there are some libraries, yeah, to do that. Yeah, there is a library. So I just search on MOPS. There is a library to convert. So I haven't tried out myself, so I cannot recommend it. But if it's on MOPS and it seems to have quite a few downloads, and also it has been funded by IC devs, so I think it's, yeah, okay, so it's from GekTech. So if it's from him, I can attest that it's gonna be a good one. I have trust. I haven't tested it, but you can convert from time to dates and from text. So yeah, the manipulation, like traditional manipulation of dates, you have that here in this library in case you need that. Yeah, time.now gives the nanos. Yeah, that's exactly, you probably need to take a look into that, into this library. Is there any question on the HTTP outcalls or what we've done here, the ICP USD exchange? Okay, so if there is no question, we can stop here. I don't have more to say about the HTTP outcalls. Of course, time library, yeah, I can post that. It's this one. Of course, what we've done with a get, you can also do it with a post. So there is also an example for the post request where we would like to post something to a server. The main difference is that you need to be very careful because if you do a post request with a canister, you have to think that under the hood, all the nodes are going to make the post request. So you are going to have multiple post requests, and you need a way to handle that at your server, the server that is receiving the post request. So there is something called idempotency key, which is used in the header to make sure that your server can essentially recognize that those requests are all the same and just ignore them, even if it's going to receive like one request per node. Otherwise, post requests are pretty basic and simple because, well, you're just doing like, it's just replicating many times the same request. All right, guys. So next session in 2 hours and 30 minutes, we are going to do the last project, which is project number 5. And we will learn how to build, it's here. We will learn how to build a website. Well, a very simple web page. So web page like this, that is accessible from our browser. So we will actually implement this HTTP request. Again, as I've said, this is a different type of HTTP request from what we've just done, because this one, it's the canister that received the request, and it's not the canister sending the request. So it's the other way around. And yeah, you will be able to create a web page in Motoko. So it's pretty cool. Okay. I see everyone there. Have a good afternoon and good luck. Keep building. I see you.